In this video, we're going to have a look at how to calculate the volume of a composite 3D shape. To calculate the volume of a composite 3D shape, first you want to split the shape into individual shapes. After you've split them into individual identifiable shapes, you want to calculate the volume of each of those shapes. And then you want to finish off your calculation by adding or subtracting those individual shapes together to calculate the volume or the total volume of the composite shape. So let's have a look at an example to see how this is completed. So in the example, we want to calculate the volume of the shape below. Now the first step is to break up the composite shape into smaller identifiable shapes. So having a look at the composite shape, I can identify one shape is going to be a cylinder, and the second shape is going to be a cone that sits on top of that cylinder. So to help me with my calculations, I've gone ahead and sketched a cylinder and a cone individually. And now I'm going to go through and mark in the relevant measurements. So looking at my diagram, I know the height of my cylinder is going to be 50 meters. So I'm going to mark that in there, 50 meters. And I need to know the radius. Having a look back at my example question, I know that the diameter is going to be 16, but I want to calculate the radius, so I need to divide that by 2. So my radius is going to be 8 meters. So I can mark that on to my diagram as 8 meters. I can also mark that on my cone because the radius of the base is going to be 8 meters because it joins up with the cylinder. And the other measurement I need to know for my cone is going to be the height of the cone. So going back to my original diagram, I can see that they've given me 17 meters, but that is not going to be the height of the cone, that is the slant. So running up the side of the cone. Now that is a measurement we use for total surface area and not volume. What we're looking for is the height of the cone, which they haven't given us. So we need to go ahead and do an additional calculation to find that height. Now I can find the height of my cone by using a little bit of Pythagoras. So what I can do is if I was to chop my cone in half, I would actually form a right angle triangle. And I would know the hypotenuse side of that, which is the side of my cone, is 17 meters. The base of my triangle, which is equal to the radius of my cone, is 8 meters. So I can go ahead and find my missing height value, which I have labeled h. So go ahead and write in my formula. Now it's not my a squared plus b squared equals c squared because I'm not finding the hypotenuse. I'm finding one of the smaller sides. So I can use a squared equals c squared minus b squared. So substituting in my values, h squared is going to equal 17 squared minus 8 squared, which equals 225. So if h squared is equal to 225, h is going to equal to the square root of 225, which is equal to 15 meters. So the height of my cone, using Pythagoras theory, I can work out to be 15 meters. So now I've got all of my measurements. I can go ahead and calculate the volume of each of those individual shapes. So I'll start off by calculating the volume of the cylinder. And the formula for that is pi times radius squared times the height. So now I can go ahead and substitute in those values. So pi times the radius of 8 squared times the height of 50, which is equal to 10,053.1 meters cubed. I can add that to my diagram of the cylinder up the top and then move on to calculate the volume of my cone. So the volume of my cone, and the formula for the volume of a cone is pi r squared times h divided by 3. So next I can substitute in my values. So pi times my radius of 8 squared times my height of 15 divided by 3, and that is going to equal 1005.31 meters cubed. And again, I can go and add that up to my cone diagram up the top. Now that I've calculated the volume of the individual components, I can add them together to find the volume of my composite shape. So total volume is going to equal the volume of the cylinder plus the volume of the cone. And I can go ahead and substitute in those values. So 10,053.1 plus 1005.31, which equals 11,058.41, and putting in my unit of measurement, meters cubed. So the total volume of my composite shape in the example is 11,058.41 meters cubed. Now that's an example of how we can break a composite 3D shape into smaller components to calculate the total volume of that composite shape.